All right, we are talking about three-dimensional figures. And I want to talk about the big difference between a pyramid and a prism. Are you paying attention to this?
Wow.
That's the kind of reaction I was looking for. So in a triangular, and the reason we call it triangular is the base. If you can see that, the base is a triangle. And a prism, and this one is a triangular prism. In a prism, all the sides are made up of triangles, and we come to one point. So I have different types of prisms. I have two here that I can show you, maybe. So here's your triangular prism because the base is a triangle. And here is a square pyramid. So both come up with triangular sides to a point, but the bottom is a square where this bottom is a triangle. So both pyramids, triangular pyramid, square pyramid. Got it? Now, if you look at this guy, this one is a triangular prism because all the sides are rectangular. And here's the big thing. You have parallel bases. So here you have the two bases that are triangles, one facing you now and one facing you now. And you have three sides to connect them. If you take a look and you see this, that is the big difference. You have a triangular base, but there's not a parallel side. They come to point. The faces are called triangles. So these are your faces, where these are rectangular faces. Okay, so now that we've got that, you tell me, prism or pyramid? This is a prism. How many sides does it have?
8.
No, you went too far. Has 6 sides. So it is a hexagonal prism. Prism because you have your parallel hexagonal bases and you've got 6 rectangular sides. All right, smarty pants. What's this guy?
Square.
This would be considered a square prism, but we can be more detailed. If all the sides are squares and they're the same size, we could say it is a cube. Okay, so we have 6 sides and we still have those 2 parallel bases, but since all the sides are a square, we know this is called a cube. So you have 6 congruent sides. All right, this guy. Parallel sides are round, circular, no rectangles here. That is a cylinder, just like a soup can.
Some chicken noodle soup with it. It's so good.
Anybody want to tell me what this is when we're done talking about chicken noodle soup? It is a cone. See? Cone. Round base, almost like a pyramid. So, circles are their own thing. This reminds me of the idea of a prism with the parallel sides, but we don't have the rectangular edges. This reminds me of a pyramid as in it comes to the top, but it has those round edges. So this is your cone. Okay, now, what's this guy?
Square.
Well, we can be more technical than a box. It's not a square. I mean, this looks like a square, but is this a square? So
A gum container.
it is a rectangular prism. So you could look at this as a base and a base. And then your faces are different sizes because this side of the base is longer than this side. So you could look at this as a square pyramid, right? Parallel bases, rectangular sides. Or you could look at this as a rectangular prism because you would say, hey, the bottom and the top here are rectangles. And you have your 4 faces. All right. This guy? That is a sphere. What is half a sphere?
Semi-sphere.
No, semicircle, but not 3-dimensional. Hemisphere, like the top and bottom of the Earth, northern and southern hemisphere. Good enough. All right, fabulous. All right, so what sets apart the pyramid and the prism?
One's got triangles on it.
Triangles on it. Okay, there's a triangle on it. Done?
Yeah.
Nope. This one, it's not a triangle.
Yeah, but it's still got triangles on it.
All right, so it has a base, and that's what we name it by, and the faces are triangular sides. So if we would look at nets, which we're going to do next, we would take this and peel all these back. You would have this square, and then can you imagine triangles sticking off of each edge of the square? Yeah. All right, if you look at this shape, and this is the base to base, and you would fold this down, you would have rectangles coming off of it, and you'd have this one extra flap. All right, what would this look like if we peeled it apart? What would the cylinder look like if we peeled it apart? Well, you'd have two circles, right? Just like when you take off the top of a soup can and you peel it back, you have a circle. What would this be if we took a label, we cut and we unwrapped the label off a soup can? What do we really have? A straight piece of paper. A rectangle. Yeah, you'd have a long rectangle because we'd slice it here, right? And when you unroll it, you really have a rectangle that's wrapping around this. So if you ever see a rectangle with two circles flapped off of it, that is your cylinder. A cone's a little bit different. You'll have the circle and you'll have sort of an odd shape from this guy coming off of it. You have something like this. You're going to see two hexagons, and then you're going to see these rectangular flaps that we could fold back. Same thing with this. You'll see two triangles. So how do I know the net? Because I see the bases, I see parallel bases, and I see rectangular faces. Where this guy, I'm going to see one base, and then I'm going to see a bunch of triangles unfolded. Okay, so let's look at a worksheet here. All right, so we're on page 82 of our packet, and we are going to look at these nets. And it says match the net. So these are called the nets. If we would have a paper figure and we open it up, this is what it would look like. So they're showing you that this is your cube. All of these are squares. And if you look, these are your bases. Do you see that these would be your parallel bases? We could fold these flaps under, and then these sides would wrap around. So that's a cube. So you're going to take this and wrap it through. Notice the triangular sides here. This is your square pyramid. Now, this is the picture of the square pyramid. I just have a problem because it's like you would have to go down to here. I have a problem because I feel like we'd have to go down there and then up there to mark it. So that's what I'm doing. I think you're supposed to be able to go across to it, but it doesn't seem to work that way. So this one right here, square base, triangular sides, square based pyramid. You see the square base here? Sometimes I think it's helpful if we color in the base, and these are called the faces. All right, now, do you see there's two triangles here? Those two are your bases. So can you imagine folding those up and then this wrapping around it? That is this shape, which is a little bit hard to show you under here. So I had it on me. If you look, do you see the triangular side in yellow here? If I would cut this and fold it down, you would have these two rectangles and the one on the bottom. So this is a triangular prism because you've got the parallel sides. Again, a little hard to see right here. So where's this guy? It is down here, triangular prism, and this is the picture of it. So this is your triangular prism. And the reason we're taking the time to go over these is because we're going to start talking about surface area and volume. In surface area, you truly are just finding the area of all the sides. So if I understand that this shape is made up of two triangles and three rectangles, I can find those shapes easier. Okay, now, see these two flaps? They don't have to be right beside each other like this. You could have one flap up here and one down here. But this looks to me like they're rectangular, and we have rectangular sides. So these are your bases. This would be a rectangular prism. So we would take our line up here to right there. So rectangular prism. Right here, hit rectangular prism and come over here. These are those two shaded sides. One's over here, you just can't see it. Okay, what's this one? Here's the base, but all the faces are triangles. So it's very similar to this, where we had a square base and all the sides were triangles. This is going to be a prism, and it's a triangular prism. Now, they call it a tetrahedron, but you see it says triangular base prism. Or pyramid, sorry. So hit that and then come back down. All right, last one. I mean, we only have one option, but what I need you to see is there's a whole bunch of these flaps, but there's only 2 of the hexagons. Do you see that these would be your parallel sides? And then if we would fold this up over, you would see these flaps would close in, and this would make a hexagonal prism. Now, I think the whole worksheet was supposed to work like that, where you cut a diagonal, it hit the name and the shape, but it didn't seem to work to me. Okay, those are our shapes. Now, you have the next step. I'd like you to take a minute, flip it over. For each 3D shape, circle the correct net from 3 choices. So this is your shape, the first one on the left-hand side, and then you have 4 options. So I think the first one's fairly obvious. This would be your cube, and this is what it looks like. So go ahead, take a minute, and decide what these are. Let's do it. So let's talk about these. This would be a cube. So let's, like I said, we're going to name these. So that is your cube. What will we call this one? This is a cylinder. And option 1, 2, or 3? 2. What would option 1 be? That's what a cone looks like, yeah. Where it's like that snow cone cup, where this would fold up and this would wrap around and attach. Okay, this one almost looks like a star, doesn't it? But if you really look, isn't this a hexagon here? And some reason in my brain, doesn't it? It almost looks like these lines are curved. Do you see that? It looks curved, but it's not. And if you fold these triangles up, you'd have a hexagonal pyramid. Okay, what's this shape? Rectangular what? Yeah, rectangular prism. So whenever you look at it, it should be this one. Here are the 2 sides, right here and here, and this is what's wrapping around. What would this one be? This would be a triangular prism, and this would be a square pyramid. Okay, oh, I just gave it away. This one is a square pyramid, isn't it? Square. All right, so why are these nets so important? Well, one, you've learned them. You've gone over them elementary school several times. The reason they're so important is I'm going to ask you for the surface area, which would be the area if we had to paint this. So if I can imagine peeling it back, having 4 triangles, if this is a square, I'd have 4 congruent triangles. That saves me time. Okay, and then we find the area of the triangle and the area of the base. All right, well, we just talked about this one. This one, here are the bases. It is a triangular what? This is a prism. So it's got to be this one. All right, next page. We have what here? That is your cone, and it is your odd-shaped one here, where this is your cylinder. Okay, this one has how many sides for its bases? The bases are the parallel sides. 6 sides, right? So it's a hexagonal prism or pyramid? Prism, because we have rectangular faces. All right, so which one did you pick? Yeah, the second one. Do you see your 2? If you can just look at it and separate instead of looking at it like some weird shape. Bless you. Okay, we didn't see this one. And honestly, I'm not sure if I have the name of it, but it's made up of 2 triangular pyramids. Now, it's hard to see that this is a triangular pyramid. It could look like a square, but we don't have that other side. So this is a triangular pyramid, and it's actually this picture right here, which is, I think, very hard to see. All right, look at this one. This is a triangular pyramid. So this is 2 of them stacked together. This is one of them. So this is a triangular pyramid. All right, which is the net? Should be this first one. See your triangular base? This one is a pyramid, but it's got a square base. This one is a triangular prism because of the rectangular faces. Okay, how many sides does this base have? 6. The thing is, it comes to point, guys, so it's a hexagonal what? It's a hexagonal pyramid. All right, so how does this come together? This has two sides, right? These are the two hexagonal, and they have the rectangular sides. This is hexagonal prism. Thank you. This is it right here. This is a triangular pyramid. This is our hexagonal pyramid. Okay, so the next thing you're going to do is you have some scissors. It's going to take, it shouldn't take too much effort, but you're going to cut out these shapes. Now notice they're named. So you're going to have to rip this page out of your packet. This creates a pentagonal prism. And you don't have to color on yours, but you see the two pentagons? The reason I'm having you take the time to cut these off is I want you to see how when you cut these out, these are the tops and bottoms, and this wraps around. Okay, this is a rectangular prism. Here are your bases, these two tabs, and this wraps around it. Here's your cube, much like a die. Mine doesn't look like a square here because it looks elongated, but it should be as close to a cube as we're getting. And then this is a triangular prism. Now the triangular prisms we saw had the top and bottom, but they had much longer. I'm trying to find it here. Like when we looked at triangular prisms, they look like this, where here you triangles and you had these long rectangles connecting it. This has short rectangles. This paper is in front of what we just did. It's in front of 82. All right, in your form, and you also have in front of that is another formula sheet. We're going to be using this one, so it's a good reference. We've got our basic areas and circumference, but then we get into talking about surface areas of the different figures, and you have volume on the back. So this is going to be a good reference sheet for us.